Welcome to the presentation. In this presentation, I am going to explain about the conversion of ER diagram to relational table. Let us start with how we are going to convert the ER diagram into a relational table. After constructing the ER diagram, it is necessary that we have to convert that into the relational models. The relational model can be easily implemented in Oracle, MySQL, etc. So it is must or it is mandatory to convert the ER diagram into a relational model. The below points are to be considered for converting the ER diagram into tables, and they are strong entity set with only simple attributes, strong entity set with composite attributes, strong entity set with multi-valued attributes, translating the relationship set into a table. How are we going to do that? Binary relationships with cardinality ratios, binary relationship with both cardinality constraints and participation constraints, and the binary relationship with weak entity set. To start with, how to convert the ER diagram into a relations table when the strong entity set having only simple attributes. Here, a strong entity set is one with only simply attributes will require only one table in the relationship model, relational model, as it is shown in the diagram. Here, the attributes of the table will be the attributes of the entity set also. The primary key of the table will be the key attribute of the entity set. If you notice the diagram, ER diagram given in the slide, here for this entity set, the simple attributes are register number, name, date of birth, etc. When you convert this ER diagram into a relational table, the table contains the column values, that is the attributes. The simple attributes are directly given as the column names in the relational table, like register number, name, date of birth, etc. in each column. The strong entity set with composite attributes are there. Then how it will be converted to relational table. Here the composite with the composite attributes will require only one table in relational model, while conversion, the simple attributes of these composite attributes are taken into account, but not the composite attribute itself. For example, in the ER diagram given below, for the student entity set, here the register number is the simple attribute. It is directly given in the relational table, and whereas the name is a composite attribute. For this composite attribute, the simple attributes like first name and last name are considered in the relational table. Likewise, for the address, which is a composite attribute, for that the simple attributes available are door number, street, city, etc. And these simple attributes of the composite attribute address is considered in the relational table. This is how strong entity set with composite attributes are converted into the relational table. Third one, the strong entity set with multi-valued attributes. While considering this, A strong entity set with any number of multi-valued attributes will require two tables in the relational model. One table will contain all the simple attributes with the primary key, whereas the other table will contain the primary key and all the multi-valued attributes. For example, in the ER diagram given below, in the student entity set, the simple attributes like register number and the name are directly given in the first table as they are considered as the primary key. Whereas in the second table, it contains the primary key and all the multi-valued attributes. So the primary key register number is given. Phone number is the multi-valued attributes that is also associated in the second table. How it is actually related in the relational table means the strong entity set with any number of multi-valued attributes may be converted as given in the diagram. So here the phone number is a multi-valued attribute. So the particular student or the particular person may have n number of phone numbers. They are considered as multi-valued attributes and that is recorded in the second table in the particular. Next, how to translate the relationship set into a table is discussed in this slide. A relationship set will require one table in the relational model, and the attributes of the particular table are the primary key attributes of the participating entity set will be there, and then its own descriptive attributes, if there anything, that will also be recorded in the particular table. So if you consider the ER diagram given in the slide, when converting that into the relational table, here in the primary key attributes like employee number and department ID, etc., are considered in the particular relational table along with the participating entity set like the date of join is also considered from the relationship set. So altogether all these are considered in the relational table when we are going to convert the ER diagram into the relational table. So if we consider the overall ER diagram as a whole, three tables will be required in the relational model for this particular type. So EMP department is another table, and third one will be the works in. It will give the relationship between the EMP and the department. Coming to the binary relationships with the cardinality ratios, there are four types possible. First one is binary relationship with cardinality ratio 1:1, and the second one will be with the cardinality ratio 1 to many, and third will be the cardinality ratio many to 1, and fourth one will be the cardinality ratio many to many. We will see one by one. So here if you consider the example given below, here the relationship set counselor will be between the faculty entity set and the student entity set, and it may have the cardinality mapping like 1:1, 1 to many, many to 1 and many to many. To distinguish these types, either a directed line or an undirected line between the relationship set and the entity set will be considered or to be given. For example, if you go with the first type like binary relationship with cardinality ratio 1 to 1, here the line from the relationship set like the counselor to both the entity sets will be given in the figure, and both are directed line. So this indicates that the faculty may counsel at most one student. Similarly, one student may have at most one counselor. Coming to next type, binary relationships with cardinality ratios. In that, the cardinality ratio 1 to many. In this category, again, a directed line will be from counselor to faculty entity set, whereas an undirected line will be given between counselor and the student entity set. This indicates that one student may have at most one counselor, whereas one faculty may counsel many students. Coming to the third type, here the cardinality ratio is many to one. Here both the lines will be undirected line from the relationship set counselor. It indicates that both the faculty may counsel at most faculty may counsel at most one student. Similarly, a student if we go to a student, the student may have many counselor, because the undirected line is between counselor and faculty entity set, whereas a directed line is between counselor and student entity set. It indicates that the one faculty may counsel one student, that means at most one student, but a student may have many counselors. To the last type, where the cardinality ratio is given as many to many. Here both the entity set will be connected with undirected line from the relationship set. It indicates that both the entity sets faculty, that is faculty and the students, if we consider, a faculty may counsel many students. Similarly, a student may have many counselors. So this is how this binary relationship is connected. Next topic we are going to see is the binary relationship with both cardinality constraints and participation constraints. Here in the example given below, we have two tables, table A and table B, which is connected with the relationship set R. Here, as the cardinality ratio is 1 to n, so the entity set B and the relationship set R may be merged. So that because of the total participation, the foreign key A1 has occurred not null constraint, so it cannot be null now. With the help of that, we can represent this with the help of two tables, like the table A will have A1 and A2, whereas the table BR, that is merged entity set B and relationship set R, will have the attributes like A1, B1 and B2. So here the A1 is foreign key A1 has occurred not null constraint, so it cannot be null now, and this is given in the table BR. Now the next one is option 2 is the binary relationship with cardinality constraint and total participation constraint from both the sides. So here, if there is a key constraints from both the sides of an entity set with the total participations, for example, A1, A2 and B1, B2 all have total participation, then the binary relationship is represented using only single table, that is A or B, where A1, A2, B1, B2 will be the constraints. Coming to the next type, the binary relationship with weak entity set. Here, the weak entity set always appears in association with identifying relationship with total participation constraints. And here also two tables will be required. The first table will be denoted as table A. It will have the keys A1 and A2, whereas the merged BR table will have the keys like A1, B1 and B2. Here the A2 is a weak set. With this, I just complete the topic of conversion of ER diagram into relational table. Thank you for visiting this video. Thank you.